Hello everyone, welcome to our first video for chemistry survey. Because this is our first video, I would like to tell you how you would be watching the videos for this class. Please take out a notebook or a piece of paper, a pen or a pencil, so you can get ready to start taking notes. Watching a video for a class is not like watching a movie. What we have to do here is to pause the video whenever you feel like you have to write down a definition, and because you can hit the pause button, you will do that, write down the definition or concept, and then you can go back and press play. Now, if you didn't understand a concept, you can always re-watch the video or just go to the part that you didn't understand. This is something that I find very easy to do because, for example, when we're in a class and it's a lecture, the teacher sometimes doesn't stop and you might have questions. So when you're watching a video, it's always easier to go back and listen again to the concept or definition that you didn't understand, and you can take as much time as you need to understand the concept. It looks like we're ready, so let's start our video on atomic structure. What do we know so far about the atom? Well, today in the 21st century, we know that an atom can be broken down into subatomic particles. And we also know that these subatomic particles can be broken down into elementary or fundamental particles. For this class, we're not going to study this last part. We're just going to study the atom and the subatomic particles that make up an atom. So the things that we have highlighted in yellow are the things that we're going to study for the class. Let's begin by defining what is an atom. So the atoms are the building blocks of matter, and there are more than 100 known kinds of atoms because those would be the atoms that make up the elements that we know in the periodic table. So another definition for this will be that the atom is the smallest unit that defines a chemical element. And here we have two examples of atoms. The one on the left is a hydrogen atom, and we see that it is composed of some particles that are within the atom. And here we have a carbon atom, which might look like something that you're familiar with. And we also see that these tiny structures are the ones that make up the atom. So what are these tiny structures? Well, that's what we're going to learn now. We see that we have three particles within the atom. These particles are protons, neutrons, and electrons. Let's start with the protons. Protons will be located in the nucleus of an atom, and they have a charge of +1 and a mass of almost 1 AMU. Now here we have different words that are probably new to us. The first one is the nucleus, and the nucleus will be the tiny central part of the atom. So if we take a look at our diagram or illustration, we see that the nucleus is this tiny part that is located right in the center of the atom, and that's where we find the protons. Another new word that we see is AMU. AMU stands for atomic mass unit, and that's a unit we use to indicate a mass on the molecular or atomic scale. 1 AMU is equal to 1.66 times 10 to the -24 grams. Now, if you feel you need to pause the video, please pause the video so you can take notes. Okay, let's continue. We also have the neutrons, which are particles in the nucleus. So again, they will be inside the atom and right there in the center. And the neutrons have a charge of 0, so that means they're neutral. That's why they received the name. And the mass is almost similar to that of the proton. So it's very, very close to 1 AMU as well. Finally, we have the electrons, which are located on the outside of the nucleus. That means that they take up the rest of the space in an atom, and their charge is -1. And the mass, compared to the protons and the neutrons, will be about 0 AMUs. So these electrons are very, very light particles. Here we have a table that is kind of like a recap of our subatomic particles. We have the name of the subatomic particle, the symbol. For proton, we will have a P with a positive sign. For a neutron, an N with a 0, and an electron will be an E with a negative sign. The charge will be +1 for protons, 0 for neutrons, and -1 for electrons. And here we have the mass in AMUs. Now you see that the protons and the neutrons are very similar. However, neutrons are slightly heavier than the protons, but pretty close still, 1.007 and 1.009. Electrons, on the other hand, are much lighter. Now, if we convert this mass in AMUs to mass in grams, this will be the numbers that we would be dealing with. And finally, we have the location. So both proton and neutron will be inside the atom in the nucleus. So again, this tiny central dense part, and the electrons would be outside the nucleus. So right here. And if you want to write down a definition for the location of the subatomic particles, this will be a great way to do it. Here we have for protons and neutrons, their location is in the nucleus. Remember, the nucleus is the central, small, and dense core of the atom. And for the electrons, we have that they are floating around in this cloud. The cloud, we will learn later on that it's made of different energy levels or orbitals, and the electrons take up most of the volume of the atom. Now let's talk about the atomic number. We know that elements are different because they contain a different number of protons. Now, the number of protons in the nucleus will determine the atomic number of an element. So that means that the atomic number will be equal to the number of protons in an element. And this is the definition we have here. The atomic number is always equal to the number of protons in an element. For atoms that are neutral, we also know that the number of protons will be equal to the number of electrons. However, you have to be very careful here because this only works for neutral atoms. Again, if you need to pause the video, please pause the video so you can write down the definitions. Now, you might be wondering, where do I get this information from? Well, we can get this information from the periodic table of elements. And here we have periodic table, and we see all the elements are here all around. And we're gonna we're gonna take a closer look to this element that we have here on the top, because this is gonna explain to us how to get the information from the periodic table. So we have here this element, which is silicon. This is the name of the element, and then Si will be the symbol for the element. Again, all elements will have a symbol and a name, and the symbol usually has 1, 2, or 3 letters. The first letter is always a capital letter, and the second or third letters will always be small case letters. And that's a rule for all the elements in the periodic table. Now, here we see on the upper left corner that we have number 14. This number is the atomic number. This is the number of protons that we can find in an atom of silicon. 14 protons in the atom of silicon. Now, if this atom is neutral, then the 14 will also be equal to the number of electrons. Here we have another example. In this case, we don't have the periodic table, but we have a list of elements. The elements are here. Here are the symbols, and we can see that those that only have one letter are always capitalized, and the ones that have 2 letters for their symbol, the first one is a capital letter, and the second one is a small case letter. We have on the first column the number of protons, and because these elements are neutral, these atoms are neutral, the number of electrons will also be equal to the number of protons. And this number right here will be equal to the atomic number of this element. So again, same definition, number of protons is equal to the atomic number. Another concept or definition that we have is the mass number. The mass number will be equal to the number of neutrons and the number of protons inside an atom. Now, why is this so? Why don't we take into account the electrons? Well, most of the atom's mass is concentrated in the nucleus, and it depends on the number of protons and neutrons. So the nucleus is the thing in the atom that gives it its mass. Remember, we mentioned that electrons are very, very light, so we actually ignore the electrons when we're talking about the mass of the atom. So the definition will be the mass number is equal to the total number of protons and neutrons in the atom. And when we calculate this, we will add up the number of neutrons plus the number of protons, which is also the atomic number. Please write down this definition. Again, we obtain the mass number from the periodic table. Let's go back to our example of the silicon atom. So on the upper right corner, we have this number right here, and this number is equal to the mass number. This is the atomic weight of the atom. So that means that we have a mass of 28.09, and from this number, we can know the number of neutrons that are in this atom of silicon. Let's go back to our table where we have the elements. Remember we talked about the atomic number, which was the number of protons, and if the atom is neutral, it would also be the number of electrons. Well, now we're going to add another column, which is the atomic weight. And remember that this atomic weight we can get from the periodic table. So this information will always be available to you. Now, the number of neutrons in a hydrogen atom, for example, would be the difference between the atomic weight and the atomic number. So here we would do we have a subtraction to make, so 1 minus 1 will be 0. So this hydrogen atom has 0 neutrons. But then we have, for example, let's go to this one, carbon. So carbon has, we 6 protons, which will be the atomic number. So here for atomic number we have 6, and then the atomic weight will be 12, and this information we get from the periodic table, so you would always be able to find out this information. When we do the difference between 12 and 6, we get as a result 6. So in this case, this carbon atom has 6 neutrons. Now, not all the atoms will have the same number of neutrons, but this information will be on our next video, and the next video will be about isotopes. So I hope you enjoyed the video, that you took notes, and I'll see you in class. Have a nice day.